Well, good morning, everyone. Today is October 23rd, 2024. Welcome to another live session. Now, let's check our course outline just to be sure. So Unit 2 test has been completed and the marks have been released, so you can please check to see if you have any issues or concerns. Just email me. But yes, your marks are updated up to that. The next assessment that will be on Unit 3, Lessons 1 and 2. Check your understanding. Then after that, we have a quiz on Lesson 3 and 4. And then 5, 6, check your understanding. This is how far we're going to get for the midterm marks. So the midterm mark will not include your Unit 3 assignment, and most likely will not include your check your understanding for Lesson 7 and 8. This one may be, depending on the timing, may be included in your midterm mark. It may not be, but definitely up to here, you will have your midterm mark. So yeah, that's something that I had a few questions about. So let's start today's lesson, which will be on Unit 3, Lesson 1. Actually, I think I already have this opened. Review of exponential functions. So from grade 11, hopefully you remember the exponential functions. Pretty basic stuff. Y equals a times b to the power of x. And b is kind of your base number. It can either be a growth or a decay factor, depending if b is greater than 1, then it's growing. If b is between 0 and 1, such as a fraction or a decimal, then it's decaying and it's getting smaller and smaller over time. A is your initial amount, y is your future amount, and x is the number of times a has increased or decreased. X being your total time divided by the time it takes for one growth period or decay period. So this is usually in terms of half-life or another, like if it's growth, then population growth. Example 1, we have an insect colony that has a current population of 50 insects. Its population doubles every 3 days. What is the population after 12 days? Very basic stuff. We know the population is doubling, so this is growth. That's your b value. So your number inside the brackets is 2. We know the initial amount is 50, so that's your a value, so 50 times 2. And the exponent is total time divided by the time it takes for one growth period. So how long does it take for the population to double? That is 3 days. So your denominator for the exponent is going to be 3, and then your total time is 12 days. So 12 divided by 3, which is 4, then 2 to the power 4, which is going to be 16, and 16 times 50 is 800. So the population after 12 days is going to be 800. And another question is, how long will it take for the population to reach 25,600? That is an example of your future amounts. So they're asking you how long will it take, so they're looking for time. So substitute 25,600 into your y value, divide both sides by 50. You have now 512 is equal to 2 to the power of t over 3. And you take logs of both sides. And when you take logs of both sides, there's a property of logarithms that you can take the exponent and take it and put it in front of the log. And now t over 3 is in front of your log, and you can divide both sides by log 2. And log 512 divided by log 2 is just a number. Just plug into your calculator. You'll get 9. 9 is equal to t over 3. And t is equal to 27 because you bring the 3 over and you multiply it by 9. So it will take approximately 27 days for the population to reach 25,600. Or not approximately, exactly 27 days in this case. Let's review inverse. What are inverse of functions? Well, inverse of functions are graphically, they're something that is reflected in the line y equals x. What does that mean? If I were to draw a line at y equals x, and imagine that's a mirror plane, and if I were to then take my original function and reflect it across that diagonal mirror, then the reflection would be the inverse function. And I'm going to show you an example of that. Now, algebraically, that's graphically. Algebraically, the way to find an inverse of a function is to follow these 4 steps. Replace f of x with y to make the notation a bit easier. Then you have something like y equals a function. Then you switch your x and y variables. You isolate for y. And once you've resolved the equation for y, you replace y, in this case, with f minus 1 brackets x. And this is not f to the exponent -1. So don't confuse this minus 1 as an exponent. This is just inverse notation. So yeah. So the inverse f of -1 x is equal to 5 plus or minus square root x minus 1 over 3. And I'm going to show you how to do this, because this is a little bit more difficult. So step 1, write y equals instead of f of x equals. Now once you have y, swap your x and y's. So this becomes x is equal to 3 times y minus 5 squared plus 1. For a quadratic equation, make sure that you are in vertex form. Otherwise, it will be very difficult for you to find the inverse. So if your quadratic is in standard form or in factored form, expand it out and then complete the square to rewrite it in vertex form. Once you have it in vertex form, it's fairly easy. You just swap your x and y, and you start bringing everything over to the other side. So we're isolating for y, so we're moving the 1, so that's x minus 1. We're moving the 3, that's going to be divided by 3. And this is my equation now. At this point, we're going to take the square root of both sides. And remember, square root and square, they cancel out. So we just have y minus 5 on this side. And on this side, we have square root of x minus 1 over 3. And whenever you have a square root, make sure you are putting that plus minus sign in front. And now bring the 5 over. And at this point, it's up to you if you want to write the 5 in front or after the square root term. That doesn't really matter. All that matters is this is the equation. And the final step is to rewrite it in proper notation. So the inverse of f of x is equal to 5 plus and minus x minus 1 over 3. That's how you do it. Okay. Let's go back. Oh, and review of exponent laws. This is from the 10 or 11. Product rule. So if you have 2 terms with the same base value, that's important. You add the exponents if they're multiplying. So if you're multiplying 2 terms with the same base value, you add the exponents. So x, that's, product rule, x to the power of a plus b. Quotient rule, same thing, except in this case you're dividing. So you subtract the exponents, from the numerator minus the exponent from the denominator. Remember, this only works if your base values are the same. Power of a power rule, in this case you have brackets and 2 exponents, so you multiply the exponents. Negative exponent rule, so anytime you have a negative exponent, x to the power of negative a, it's equal to 1 over x to the power of positive a. This is how you can rewrite negative exponents in terms of positive exponents. And the exponent of 0 is just equal to 1. So anything to the power of 0 is 1. Now we're going to figure out, example 3, we're going to find the inverse of f of x equals 2 to the power of x. How do we do this? So remember the rules for inverse. We are going to rewrite it in terms of y. That's the first rule. So this becomes y is equal to 2 to the power of x. Then we are going to swap my x and y values. So now this becomes x is equal to 2 to the power of x is equal to 2 to the power of y. We want to isolate for y, but y is in the exponent. So how do we bring it down? And the way to do that is to take logs of both sides. And what does it mean to take logs of both sides? Well, I take the log of everything on the left hand side, and I take the log of everything that's on the right hand side of the equal sign. And now that I've done this, I can bring my exponent down. And this becomes log of x is equal to y times log of 2. Divide both sides by log 2. Cancels this out. Y is equal to